everybody, welcome back to another video. In this video, I'm going to be clearing some of the important physics questions that you have in grade 9. Now, people that are writing their exam in class 9, just watch this video, make a note of some of the questions I'm going to tell you, and you're definitely going to get marks, okay? So I can guarantee you around 10-20 marks, right? For the rest of the marks, you have to work hard. Basically, I'm telling you the ways they ask questions, the important questions from each chapter I'll be discussing. Now, if you look at your grade 9 syllabus in physics, you have a total of 10 chapters, that is considering ICSE. Each of these 10 chapters have certain questions, certain areas you need to pay attention to, and I'll be clarifying all of them now. Now, before we actually begin discussing the questions, I would first want to tell you how your question paper is generally asked. First question is usually 15 marks MCQs, right? For all schools, 15 mark MCQs are there. Now, these MCQs will be from all 10 chapters, right? These MCQs are usually easy. You'll have at least one assertion-based question and one picture-based question. So for history, so for physics, right? And next, so after 50 marks, plus you'll be given 6 marks. 6 marks for maybe some short, name the following, short answer, some question like that will come for 6 marks. Then another 4 marks will be more short answers, right? Like maybe differentiation or maybe give reason, short 4-marker questions. Then you have 15 marks, basically it's a whole section. So in those 15 marks, you have questions that are compulsory to attempt. You don't have a choice, means you have to attempt all those questions that are asked. So that is section A for you. So 15 plus 10 plus another 50. That is 40 marks in section A. Section B, usually you get 5 to 6 questions. Within those 5 to 6 questions, you have to attempt any 4. Means each question will be 10 marks. So you have to attempt any 4 with the best of 4. If you want to get attempt an additional question, the best of 4 will be taken into account. So that is how the paper will usually be asked. Now I'm going to tell you certain questions that have a huge probability of coming in your paper. So remember them thoroughly. First chapter that you have in your syllabus is measurement, right? You have measurement in your syllabus. Now, what are the different questions that come from measurement? Question number 1, learn the conversions of units. Difference between scalar units, vector units. Scalar units only depend upon magnitude, whereas vector units depend upon magnitude as well as direction. Question can come from there. Then give examples of scalar and vector units, another thing. Then that's not the only thing. Then you have to learn the units of length, the units of time, all these different things you have to remember, right? And then the CGS system, SI system, all these different systems of writing units, guidelines for writing units, learn any 3 points, and you're good. From that part, the conversion of units, you'll usually be asked in MCQs, like, okay, how much is, like, for example, you have convert joules into calorie. 1 calorie is equal to 4.2 joules. Conversions of units means there's lots of units you have to learn. You have light years and you have micron, parsec. All these units, just learn them. Okay, they come for marks in MCQs. So usually some 2-3 questions are asked from just conversion of these units. Remember them carefully. So from unit 1 of measurement, just the conversion of units are important and differences can be asked. That's pretty much it, right? Now, unit 2 and 3 are your screw gauge, vernier calipers, and pendulum. Now, some of you, it may not be tested. For some of you, it would be tested. Usually, there's going to be a question guaranteed from either vernier calipers or screw gauge. So you will be given a vernier calipers, right? You will be given a vernier calipers, and it would have some kind of error. So they'll give you a vernier calipers, and they'll say, okay, identify the following image. So you have to say it is a vernier calipers, right? Then second thing, how do you calculate the least count? Write the formula to calculate the least count. So you have to say the lowest division on the main scale divided by the number of divisions on the vernier scale, right? I think that's the formula. And then if they ask you for pitch, like for example, they can also give you screw gauge. They can say, okay, find the least count of the screw gauge. You can say the pitch of the screw divided by the total of divisions on the circular scale, right? That is a formula to calculate least count. So they'll give you one of this. Then they'll give you the thing with a 0 error. Then they'll say, name the kind of error that is found in this following instrument. So you have to say it is either positive 0 error or negative 0 error. Some cases, what they'll do is they will give you a vernier calipers or a screw gauge that is free from 0 error. Then they'll ask you, is this instrument free of 0 error? Justify. Whenever they ask you that justification, you have to say, because the lines, the divisions are coinciding, therefore it is free from 0 error. That is the justification you have to give. So 3 to 4 marks I can guarantee you from vernier caliper screw gauge. Pendulum, learn the formula, learn the factors affecting pendulum, learn the seconds pendulum concept, and you're good with pendulum. Okay. Pendulum related numerical always comes. Make sure you know how to answer it. And all those parts of a pendulum, all those basic things related to pendulum, just remember it in detail. So if you remember all these points, you'll get around 8 to 9 marks in your paper. I can guarantee you. Apart from that, you have additional questions also, so you'll be given even more marks. Got it? Depending on what you attempt, you'll get marks. Next chapter, we have heat. Now, heat, as you guys know, most of this is cut out. Second, third, and fourth unit, those completely cut out all the renewable sources, non-renewable sources. Those are never really tested. What you have to remember in heat is the concept of anomalous expansion of water. That concept comes for 3 to 4 marks always. The graphs, okay, the graphs related to anomalous expansion and the concept, the definition of anomalous expansion. All those graphs and everything related to anomalous expansion is a 3-marker. Hope's experiment, go through it in detail. It always comes for a 3-marker. Don't skip that concept. Next, differentiate between heat and temperature. Know that. Then how do you convert, let's say degrees Celsius into Kelvin and degrees Celsius into Fahrenheit? All these conversions are also quite important. Then calorie to joule, then erg, all these other units related to temperature, heat you need to remember. Got it? That's all you need to remember in heat. Then second part of it, you have the thermodynamics part. Just learn the 2 laws of thermodynamics. First law is that, energy can neither be created nor destroyed. Okay, just turns basically the same as law of conservation of energy. Then second law of thermodynamics is that whenever, the heat gets, transported or something. It doesn't always get transported fully. That's not the exact statement. You have to write the exact statements. Like they can say, state the two laws related to thermodynamics, right? Or they can say, state the second law of thermodynamics and state its application. So the application of the second law of thermodynamics is always in the food chain. Got it? So related to this, please learn the two laws of thermodynamics and the application of the second law. This question is guaranteed as an MCQ, 2 marks. Any goddamn exam you write, you'll always see this question, because heat is one full chapter. And in heat, you just have to learn 3-4 different concepts. That is it. Anomalous expansion related questions also, they can give you like word problems, or like they can give you application-based questions. Like they can say, how does it help in preserving aquatic life? All these are different pointers that will come under heat. So heat is a pretty important chapter. Don't skip it. Easily you can get 6 to 7 marks. Measurement is also easy chapter. Next we move on to light. Light is a very, very, very scoring chapter. Okay, it is a very scoring chapter. I'll tell you the different things you need to remember in light. Now, related to light, first of all the numerical concepts that will come for around 3 marks. 3 marks, all the focal length, radius of curvature, image, size of the object, all these different mirror formula, all these different numericals that come under light come for 3 marks always, right? 3 mark numerical, like let's say calculate the focal length. All these are 3 mark questions. They will come as a 3 mark. That's the first thing. Next, they'll give you a ray diagram for 3 marks. Now, a ray diagram is usually for 2 marks, but after you draw the ray diagram, they'll give you a follow-up question, right? They'll always give you a follow-up question. They'll say, like, for example, okay, state the characteristics of the image. Like 2 marks for drawing the ray diagram, 1 mark for stating the characteristics of the image that is formed. Or sometimes they can give you a 4 marker. Draw the ray diagram, then state the characteristics of the image formed, 1 mark, and which type of mirror is used in the following, and what is its use, like what is its application, right? How is this mirror helpful to us? So, like, most of your diagrams are with concave mirrors, so you have to, give any application of it in real life. These are all questions that will come from light. Got it? Next, you need to remember the number of images formed. That concept is very important. Second unit, the number of images formed. How will you learn that? First of all, always remember there's 2 cases. Okay, there's 2 cases. Whenever you get an angle that is given to you, divide it from 360. So it's always 360 by theta, which is equal to n. Now, there can always be 2 scenarios, because whenever they're even, though by default you have to do n minus 1, right? And whenever there's odd, there's 2 scenarios. If it is symmetrically, it is n minus 1. If it is asymmetrically, it is just n. So remember these formulas, very crucial to score marks. This question, 360 divided by theta, number of images formed, comes always as a 1 or 2 marker. Remember that concept well. Then ray diagram you have to learn. That's guaranteed. Learn the uses of concave mirror. Then the characteristics of the image on a concave, convex, whereas plane mirror. Application based question comes next. Learn the 360 divided by theta thing. Then one more type of question that comes from here is, what they do is, this is your mirror. And they say that I'm standing, for example, 2 centimeters away from the mirror. So my object will be formed 2 centimeters behind the mirror. So what is the distance between me and my object, right? Me and my image. So it'll be 2 into 2, which is 4. So now let's say I move 2 centimeters away from the mirror from my mean position. So I'm 4 centimeters away from the mirror. That means my object is also 4 centimeters behind the mirror. So what is the distance between me and my object? 4 into 2, which is 8 centimeters. Related to that also, you get numericals. Got it? Light is a very scoring chapter. Make sure you learn light. All definitions also that come under light. Light is very, very simple to score. This chapter, always learn it. And in the numericals, be very cautious of the different signs that are asked. Got it? Light is also very easy. 10 to 12 marks guaranteed. Electricity is another very simple concept. I think you have to remember the basics. First of all, in electricity, there's not much to do. That's why learn everything thoroughly. Electricity, the main thing they ask you is the second part, that is Ohm's law. So learn Ohm's law. Usually they just say state Ohm's law. Related to Ohm's law, they give you 1 numerical. State Ohm's law for 1 mark, solve a numerical for 1 mark. 2 marks guaranteed from electricity. Then second part of the question, they'll say state the direction of flow of regular current and convectional current. Regular current is from a negatively charged body to a positively charged body. Why? Because a negatively charged body has more electrons. And electrons are negative. That means it is negatively charged. Since it has more electrons, it will have more charge. So it goes there to the positively charged body to maintain an equilibrium. But convectional current is the exact opposite. Convectional current travels from a positively charged body to a negatively charged body. So in a case like that, always remember, don't mix it up. 2 marks. So already 2 marks you got, plus another 2 marks, 4 marks. Then remember the circuit diagrams, another 2 marks I can carry to you. Circuit diagrams are important. All those galvanometer, ammeter. Learn how to draw them. Rheostat. Learn how to draw them. Practice drawing them 2-3 times. Circuit diagrams, ray diagrams always come in your exams. Got it? Next, again, calculation of, let's say, current. Current is ultimately equal to what? Charge upon time, right? And then differentiate between primary cell, secondary cell. All those different questions you can get. Then one more question you can get is, let's say, differentiate between AC and DC current. Again, all important questions. So related to electricity, whatever you feel is important, do everything. Don't skip anything. Do everything related to electricity. Second part, potential difference. Resistance is important. That's very important. Factors affecting resistance, which always comes in your exam. Okay. So if the wire is increased, like if the thickness of the wire is increased, there'll be less collisions, right? There'll be less collisions. That means there's less resistance. The more collisions, the more resistance. So there'll be less resistance. So the wire is, made thicker. Whereas if it's thin, it'll undergo more collisions. That means more resistance, right? Next. Magnetism, just learn the definition of induced magnetism, magnetic induction with the example. Always comes for a 2 marker. Next question, neutral points. Learn the neutral point concept. Very, very important. Always comes. Then what happens if if a magnet is tilted in its north direction towards the geographic north? Those 2 diagrams, those 2 case studies, learn them thoroughly. Learn the role the neutral points played. Learn how to draw them. Right? You can be asked. Then properties of magnetic field lines. 3 marks, 3 points you have to give. right? 2 marks usually comes from properties of magnetic field lines. Learn how to state that. Another important question that we ask from magnetism is give any two, give any two instances to prove that the Earth is a magnet. First of all, the compass always points in a geographical north-south direction. That's very necessary. That proves that it is a magnet, right? And then if you take a iron piece and bury it within the Earth, it becomes a magnet, right? These are two instances where the Earth acts as a magnet. So you have to give these two reasons. Very, very important for the exam. It always comes. So this is the first unit related to magnetism. Second unit also magnetism has. Now within that, there's always a the electromagnet concept. Electromagnet, temporary magnet, permanent magnet. That concept differences, uses all these points, learn them thoroughly. Very important for exams. They'll give you an electromagnet diagram. They'll say, okay, label the polarity of it. Questions like that will come. Usually electricity and magnetism are one set. So you get a whole section related to just these two. Electricity, magnetism comes together. So if you learn these two chapters well, you can get 10 marks because they usually come together. Electricity, magnetism. Got it? And then learn the application of electromagnet in an electric bell. Okay, that again is very important. Okay, next we come to sound. Sound is again important. Sound, the most important part is the factors affecting sound. Very important. Then the different frequencies, the we have infrasonic, subsonic, supersonic frequencies. Then you have that, requisites of the medium of propagation of sound. 2 points, you have to learn any 2 points. Sound cannot travel through vacuum, right? Whereas light can travel through vacuum. Then the echo concept you need to remember. Related to that, they give you word problems. Then the basic numericals for sound. Then the terms related to it. You have amplitude, frequency. All these are different things that come under sound. Okay. Then you have learn the requisites of medium of propagation. 2 mark guaranteed. Learn numericals. All the numericals related to it. Like the wavelength related numericals. Those are the ones that always come. Speed is equal to distance over time. General formula comes. 2-3 marks usually it comes under. Then the factors affecting sound. That's all. Just learn them. You're set for sound. And then learn the different frequencies of sound. That's it. So the next chapter we are going to look at is force. Force is a chapter again which focuses a lot on numericals. Do the numericals related to force. Okay, pressure is equal to force by area. Basically Pascal's law you have to state, right? Very important. Just first unit is easy. Then they give you give reasons based on it. Right? For example, you have these under like divers, right? Sea divers. Why do they wear specialized suits? Basically everything related to pressure is under this force chapter. Okay, so force unit 1 is very easy. Then we learn about liquid pressure in liquids. That H rho G derivation. Now derivations, let me tell you, in 9th grade we don't really ask derivations. Just 5 derivations. Let me tell you are important. 6 derivations are important. First derivation is Newton's second law of motion. Second derivation is the H rho G derivation. Third derivation is V rho G upthrust derivation. Fourth derivation is the first equation of motion. Fifth derivation is the second equation of motion. Sixth derivation is the third derivation of motion. Got it? These 6 derivations, if you practice is enough, you can guarantee 3 marks. Learn the derivations, very, very important. This concept is so important, I can guarantee you marks. So force, just remember, it always comes as a 7 to 8 marker. Okay. Under force, definitely pay attention to numericals. Laws of liquid pressure are quite important, right? And then you have a second part of it, atmospheric pressure. Learn about how it, how it's used in weather forecast. Atmospheric pressure, all the different application-based questions come. 1 mark for that. Okay, application-based questions from pressure. Then that graph for atmospheric pressure. Then, like why are, noses and all bleed when we go at high altitudes. And these parts, atmospheric pressure is important. Learn that concept and learn the barometric liquid level rises, whereas falls, indication of rain and indication of storms and dry weather. All these concepts are very important. 2 marker always comes from there. Just that number 1, the barometric thing. Don't learn the barometer, Mercury, Fortin barometer in detail. Just learn basics of it. Then learn why water is not used as a barometric liquid and why mercury is preferred as a barometric liquid. Then learn the graph for atmospheric pressure and the application-based questions. That's all that's important from atmospheric pressure. Upthrust is a very important chapter. Here your numericals are very, very important. Pay attention to the numericals a lot. Okay, upthrust, what happens when the weight force is greater than the buoyant force, application-based questions, calculation of upthrust, all these different parts you have to remember thoroughly. The upthrust is a very important chapter. I would say maximum amount of time you can take because this is also, according to me, the hardest chapter that I found. If you are not able to solve the numericals, if you can't do them at all, then leave them. But do density-related numericals. Always comes density-related numericals. Relative density. Remember, it does not have a unit, right? Know how to calculate that. Know how to generally calculate density, the units, all those parts. Very, very important for your exam. Got it? Upthrust is important, especially unit 1 and unit 3. Second unit still, even though it is important, you can skip it technically. Learn the different applications of Plimsoll lines, all those parts also. The application theory part too you can do, right? That's easy. So 8 marks I can guarantee you from upthrust. Next we come to motion. Now this I'm talking about motion in 1 dimension. The graphs, all the motion graphs, learn them very well. The displacement time graph, the velocity time graph, like the acceleration time graph. Related to that, calculating area on it itself, calculating, like they'll give you a velocity time graph, you have to calculate the displacement. Whenever you have to calculate the displacement, whenever you have to calculate, remember, whenever they give you the graph and you have to calculate its slope, we always have to calculate the area, right? The area of the shape that is made, right? If you get a straight line, it would always be the area of the rectangle. So related to that, you always get a 3 mark of homework numerical related to this motion in 1 dimension graphs. Next, you maybe will get, graphs to draw also, right? To draw the graphs. All these parts are also quite important. Under motion in 1 dimension, it's an easy chapter. Make sure you do it. 3 equations for motion. V is equal to u plus at. S is equal to ut plus half at square. V square is equal to U square plus 2AS. These three equations of motion, learn how to derive them and learn to solve numericals. Derivation, any one will come, especially second or third equation of motion derivation will come 3 marks, I can guarantee you. Plus, you have to learn how to solve numericals from them. Any numerical can come from these parts. Got it? So under motion, first of all, graphs will come. Second of all, you'll have to talk about all these different, factors. All these different factors, okay? These equations, right? These three equations and how to solve numericals basically. Another part is that they'll say, okay, why is, the speed not 0 but the velocity 0, or why is the distance never 0 but the speed? Questions related to that will always come, right? So based on that circular motion thing, know how to explain that always comes, right? And then the graphs related to a freely falling body are important, okay? These are all important questions from motion. Last chapter that we are discussing is probably the most important chapter, the most weightage, that is Newton's law. Newton's 3 laws of motion. Third law is very easy. Every action has an equal and opposite reaction. Know the two different forces, that the tension force and the weight force that acts on it, right? Remember they are equal in magnitude but opposite in direction. That is something you'll also learn in 10th grade in the concept of couple, right? You'll have to apply this Newton's third law of motion. Second law of motion is where you have to focus on the numerical bit, okay? Like magnitude is equal to mass into velocity, right? This part you have to remember. And then if you look at force is equal to mass into acceleration, learn how to derive it. Important. First law, it's always inertia. First law of motion is always just inertia of rest, inertia of motion. That's it. That's all that comes. Okay. And first part of it is non-contact and contact forces, which is again a very easy concept. And last we have gravitation. Learn Newton's law of gravity. That's very important. And learn the different numericals. All it's very similar to motion in one dimension. So these are some important questions that are coming in grade 9. Okay. Learn the ray diagrams confirmed. Learn the atmospheric pressure, the weather forecast part. Any 2 marks it will come. Then learn the derivations. All 5 derivations, learn them. Any one can come for 2 to 3 marks. MCQs, I told you the trick. Learn the conversions of units. Learn vernier caliper screw gauge pendulum concept. 4-5 marks, I can guarantee. Learn the concept of anomalous expansion of water. It's impossible that doesn't come because there's nothing else from heat to even be tested, right? Then light, numericals plus ray diagrams. Do not skip it. Electricity, do not skip the circuit diagrams. Do not skip the Ohm's law concept. Remember how to solve numericals. Magnetism, again, is an important chapter. It's not that important. You can just do it. Learn what I told you. And then if you have time, read the chapter. Sound, again, you can kind of do it, but it's also quite easy. Same thing as what you learned last year. So don't spend too much time on sound. Spend time on force, upthrust, and Newton's laws of motion. Motion in one dimension. So if you get it once, then you get it. These are all important questions for physics. Okay, that's pretty much it for physics. If you enjoyed this video, please like this video, please subscribe, and thanks a lot for staying till the end. That's all that's there for that grade. Okay, thanks again. Goodbye.